What I will do is I will also reduce the number to 128. Let's see what happens with 128 here. Oh, if I go back to 128, it is 872 times faster than Python. Mojo is everywhere. I mean, think about this. The language was launched last week, and everywhere you will see this language. And the amazing thing is, we don't even have a compiler to run this programming language. Normally, when you talk about new languages, you get a compiler, you can write hello world, you can test it out. In fact, the company claims that the language Mojo runs 35,000 times faster than Python. And unfortunately, we don't have a compiler to test it. And then the company says, if you want to try out, the only thing is Mojo is still in development and they don't have a compiler ready to give it to the public. Of course, they have it internally. And as a normal person, if you want to use Mojo, you have to do it on the playground. So basically, they provide you a service, a web service, where you can basically run your Mojo code. And the bad part is you can't access the playground directly. You have to request for the access, and then Mojo will say, okay, now you have the access, you can use it. So most of us signed up for the Mojo, and now finally I got the access. So it's been 2 days I got the access, but then I was busy with some other project, and now let's explore the Mojo playground. I was able to look at the playground for an hour just to understand the different tabs and stuff so that I can show you, but then I was not able to get into the details of the coding, and I thought, let's do it together. So for me also, this will be quite new. Yeah, I have seen some of the code, just a walkthrough, just to understand what they're talking about, but most of it will be new for me as well. Okay, cool. So now this is the email, and in fact, the last time when I made the video about Mojo, there were some comments regarding the Mojo as a language because it claims to be faster, but then we don't have a compiler to test it, and it's not even open source yet. A lot of people don't believe languages which are not open source, and that is true in one case. Even I was a bit skeptical looking at this language, and let's see how it works. Now, basically, this is the mail you will receive once you get the access, and it says, welcome to the Mojo playground. That sounds cool. And my team members, they loved the logo. Not a big fan of emojis, but it looks cool. Yeah. Okay, now you can see they provide documentation, and I looked at the documentation as well. They had some snippets. They also have detailed explanation about the libraries it provides. Now, see, it's a superset of Python, right? So it supports everything which is there in Python. That's what they claim. But I think there are certain libraries which are not supported yet. In future, they will do it, but not now. So there are some FAQs. They also have a Discord, and yeah, they also have a GitHub repo. Okay. And now let's click on the playground. So this is where you can see a playground, and also let me open the documentation first. Let's click docs, and this is what the docs talk about. So they talk about why you have to use Mojo. So this is a video which I made, and then you can also try Mojo. But if you click on this, they will ask you to sign up to get the access. I got the access, but yeah, that's what you get. They also talk about Mojo programming language, the Jupyter notebook, where you can type the code since we don't have a compiler yet. And they also have a programming manual. Now this is where they talk about Mojo from the basic. Oh, not even basic. It's directly start from the important stuff which they made changes to. Now, things to remember, Mojo is basically a language which is a superset of Python. But then Python being a dynamic language, if you want to make it faster, if you want to compete with language like C, you have to make it strongly typed or strictly typed. And that's where Mojo says you have to declare the variables. Again, it's optional, but then if you want to make it faster, declare the variables. Also try to make your variables immutable, right? So that you can use concurrency, you can use multi-threading there. And they also introduce something called struct. So classes is not supported because it's more dynamic. Struct is more static. So they went for struct, which are structures basically. And yeah, you have to work with data type as well. Now, instead of using def, they also talk about using function. Now, function, fn, and definition is same with some changes. By default, you can see there's some changes here. Arguments value default to being immutable in body of a function. So that means every variable which you pass as an argument will be immutable by default. And that actually makes sense, you know. The moment you talk about multi-threading, it's great. And mutation is also great. But when you mix mutation and threads together, that's where the problem starts. And that's why if you want to make it faster, if you want to use multi-threading, try to make your data immutable. And that's what most of the languages also promote nowadays, especially the modern languages. Okay, so this is what they talk about. They also have, this is how you print, again, Python. So if you know Python, this is much similar. It's just that to try out the playground, they also suggest you should have a knowledge about Python and also some system programming concepts. Now, that's why a lot of people promote you to start your programming journey with C language or C++ instead of Python, is because you understand other aspect of programming. The moment you start with Python, you talk about just high-level language, you are not sure what is happening behind the scene. But when you learn C, C++, you understand what is happening behind the scene, right? And I was lucky because my first language was C. So that was cool. Okay, and one of the examples which we are going to focus in the playground is matrix multiplication. So this is how the formula looks like. Again, we'll try it on the board as well. So this is the code which they show. In fact, this is the code we are going to try out in the playground. So I know you're waiting for the playground. Let me show you how playground looks like. So I will click on Access Mojo Playground. It will ask you for the login first. I have already done the login. Okay, so this is the playground. So I got the access 2 days back and I created a folder, but then I have not got enough time to try it out. And today morning I tried for 1 hour, but I thought let's do it together. Okay, cool. Now, if you can see, they provide you different notebooks here. And one of the notebook is Hello Mojo. Now, this is where you can try out the code, right? So the first code, of course, right, the moment you say you are trying a new programming language, you can print Hello World. What I will do is, instead of running this code in this particular notebook, I will create a new notebook here. Notebooks. Okay, new notebook, not a file. And I will say this notebook name, yeah, so I want to use Mojo as my kernel. And do you want to name anything? Doesn't matter. Okay, so let's write our first code. So I will say print, this is the Python logic, and here I will say hello world. That's how you start, right? Or I can also say welcome back aliens. So let's write out, let's say shift enter. That's how you run in the playground. Yeah, so you can see we got the output. And again, this is the cloud service, or the processing happening on their server. They provide you with limited computing speed, so that's why it was a bit slow. But once we have a compiler to use, I think it depends upon your system speed, it will work. So here you can see we have hello world, welcome back aliens, so this is working. In fact, you can also try out different addition, subtraction, which we normally do in Python. And if you have seen my Python series, this is how I start, right? But yeah, I have to print it here. I forgot to say print. Anyway, it doesn't matter. So let me just close this notebook because we don't want to use it. I want to use their notebook. So this is the code which they talk about. Example, if you want to see if, okay, C is not D, print D. Okay, let me print your function. We are passing your function, we are passing 2, 3. What it does, so it takes 2 parameters, that's right. So we got A and B, and then C, the value for C is A, which is 2. And then if these 2 are not equal, which they are not, it will assign the value to D as B. So it should print the value of D, which is 3. Let's see if that works. Okay, that's right. So yeah, almost same Python code, but we are doing it in Mojo now. And yeah, we have different things. But if you want to see the real power of it, one of the notebook which we are going to look at is the matrix multiplication. Now this is where they talk about the speed. Now if you're not sure what matrix multiplication looks like, I will just give you a gist. Because it's been a long time I have done matrix multiplication, so I thought you will need it. Okay, so you can see we have 2 metrics here. One is A and B, 2 matrices basically. Now in the matrix, you have a dimension. So we got 2 rows and 3 columns here, so 2 into 3. And for B, we have 3 rows and 2 columns, right? Now, if you multiply 2 matrices, you have to also make sure that the columns for the first matrices should be same as the row for the second one. So these 2 need to be same, and the resultant matrices will be for this number. So 2 into 2. So the resultant would be 2 into 2. And then how do you multiply? So basically you pick up 3 from here, then 5 from here, the first row, first column, then 2 from here, 3 from here, and 6 from here, and 1 from here. So you basically multiply this number and then you add them. So 3 into 5 plus 2 into 3 plus 6 into 1, something like this. So basically 3 into 5, the first row, first column, and then 2 into 3, and then 6 into 1. So that's your first value, okay? Let me just remove this part from here because we need a bigger one now. Now for the second one, it's 5. So basically we have to focus on the second row and first column. So for this particular element here, we need to say 5 into 5, then 1 into 3, and 3 into 1. And then we have to add them. So it's 5 into 5 plus 1 into 3 plus 3 into 1. And that's how you basically calculate. And then you sum it. So for the other one as well, you have to do the same thing. So 3 into 6. So this is first row, second column. plus 2 into 4 plus 6 into 2, and the list goes on. Again, we don't want to do all this, but yeah, this is how matrix looks like. Now, if you go back to the code, this is the formula which they're talking about. This is the matrix multiplication. So we have to do summing of all the multiplication of the rows and column, right? And then you will get C. Now to do this, first of all, we have to write a code in Python. Now this is a Python code if you want to multiply the matrix. Now since we are doing all those steps, this is what we are doing, right? So basically we have to take the number of columns for the resultant matrix, which is C, get the rows, get the columns, and then you have to multiply each thing, right? So you have to multiply the first row elements with the column of the second matrices, and then you will get individual element. This is simple, right? But then it takes time. Now the dimension which we went was 2 into 3 and 3 into 2. But then think about huge matrices, and you will be thinking, why we're talking about matrices here? Why not something else? It's because if we talk about a language like Mojo, it is majorly meant for AI. Now, if we talk about AI, we get image generation, we get text generation. So normally they work with matrices, right? Huge matrix, not small one. And it's very compute intensive work. It takes a lot of time to do it, right? So if you look at the matrix here, we are looking at 128 by 128. It's a huge matrix. Okay, and then if you want to check the speed, we can do that with G-flops. Basically, we can also take it in seconds, but if you want to really compare two operations, G-flops normally work. This is the flops for your floating point numbers. How much time it takes for the floating point operations. Okay, cool. So how do we do it? So we have a particular function here. So this is responsible to basically multiply your matrix, but we want to see how much time it will take, right? So first of all, we'll run this. I will say shift enter. Now we got this function, which is matrix multiplication Python code, which takes 3 parameters or 3 arguments. Now if you want to see the speed of it, what you can do is first of all, we are creating a matrix, so you have to use NumPy. Normally arrays we cannot use in Python. We can use NumPy here for 2-dimensional. And then we also need a package called timeit, which will calculate the time of a particular function. Of course, you can also use, normally what you do is you find seconds, right? So if you want to perform an operation, if you want to see the speed, you set the timer at the start, you set the timer at the end, and then you subtract. But sometimes it will not give you accurate result. And if you really want to test something, you know, when you buy a new phone, you do benchmarking of it. In the same way, if you have a function and if you want to check the speed of it, you will run the function multiple times and you will find the average of it. And that's what you can do with timeit. Now this is, again, everything is Python, no Mojo till now. So it's all Python. Now if you want to represent a matrix, and to simplify it, you can create a class called matrix. And in this class, you will be having a value for the matrix, the number of rows and columns. And once you get this, you can generate the matrix using random numbers. So what we're doing here is we're creating a matrix, and this particular function will generate a random number of values depending upon the value you pass. So example, m number of rows and k number of columns. That's how you can do it. So it will generate a matrix for you, which you are storing in here. And next, we got one more matrix here. And again, since we have 128 by 128 values, it's a huge number, right? So I don't want to input those numbers myself, and that's why we got random function here. And the third matrix will be all zeros. So you can imagine the third matrix of 128 by 128, all zeros. And then you are performing this operation. So now you are multiplying this matrix. So you're using a function timeit to calculate how much time it will take to do this. And it can be a very fast computer, but it will still take time. So what we're doing is we are running this function 2 times. In fact, you can do it for 5 times as well, and you will find the average of it. So whatever number of iteration you're doing, just divide by that number, you will get the average. And then you can basically print the seconds. We are not printing seconds here. What you're doing is you're finding the G-flops. We'll also print G-flops, but let me also print the seconds, how much time it will take. So I will say print seconds as well, and I will just run this code. Now since we are writing Python code in Mojo, you have to add this line, percentage Python. Okay, so the function has ran. Okay, we have to call the function to run it, and this is where you can run it. So you can say shift enter. Let's see if that works. Okay, so you can see it works, and it takes 1.9 seconds. Can you see that? A particular operation of matrix, which is only 128 by 128, takes 1.9 seconds. And that's why we say it is slow, right? How do you make it faster? Now that's where we can try the same example in Mojo now. So basically, if you want to use Mojo, you have to import all these packages. Let's not get into details of this. When we start with the series of Mojo, where we talk about the basics of Mojo, we can see that. But then we don't have a timeit option. I was looking for timeit, but timeit was not working in Mojo. So we have a benchmark special package to do the benchmarking. Okay, now this is the same code in Python which we did. Nothing changed here. Because see, we don't want to change the syntax of a code which we want to test. right, then it will be unfair. When you are comparing two languages, let's keep the same logic. There are multiple ways of multiplying matrices, but this is the logic they are using, the same logic which we have done before. And then to benchmark it, what they're doing is they are basically adding the values to the matrix in a different way, in a Mojo fashion. And then they are calling this particular function, which is the multiplication, and they are calculating the speed. So instead of using timeit, they're using benchmark function to do it. And they're not printing seconds. Let me also print seconds here. And then let me just run this. So first we have to run this particular code. Okay, first we have to import. We have to run the import statements. Then we'll run this. Then we'll run this particular function, everything here. All these are definitions. And then at the end, we'll run this particular function, and let's see the speed now. So the earlier one took 1.9 seconds, right? And this is taking 0.1 second. And look at the speed now. Again, there are a lot of talks happening that we are not sure what is happening behind the scene. Maybe for running Python, they are using a smaller CPU, and for running this, they are using a bigger CPU. And that's where this G-flops comes into picture. So don't look at the seconds, look at the G-flops. And if you compare, for this particular one, it took this number of G-flops, and here it was 14% faster, right? Now, again, when you try it, it might be different because at this particular instance, the resource allocated for my particular instance might be less compared to yours. Okay, now they also do it in different fashion by adding more strictly type. If you can see, they are doing it in a different way. And since I mentioned I just started using it, so I'm not sure what changes they have done here. So adding type to the Python implementation. Okay, so now they are making strictly type. So the thing is, when you make a language strictly type, and when you determine the behavior of an application at compile time itself, with metaprogramming, it makes your execution faster. And that's what they have done. Now, instead of using a normal matrix functions, they are using a struct. Now we are defining exactly what structure you want to use. And now everything will be happening at compile time. So the optimization will be done at compile time itself. This is what they're saying here. And with this code, basically we got the matrix, and we have the same logic for the multiplication. Let's do this, let's try. So first I will run this particular structure. This is the matrix definition. Then let's run this particular function, which is the actual calculation, enter. And then we'll do the benchmark. So this is where they are doing the benchmark here. Let's try the benchmarking. And at the end, let's execute. And this time, if you can see, they are even going for a bigger matrix, not even 128. So I will say enter, and let's see the speed. And you can see it is 500 times faster, 575 times faster. That's cool. What I will do is I will also reduce the number to 128. Let's see what happens with 128 here. Oh, if I go back to 128, it is 872 times faster than Python. Okay, and now they are also implementing SIMDs. Now what happens is, when you do a matrix multiplication, now since we are going for each row and each column, Python runs in a single threaded way, right? So what it does is, it executes everything one by one. But what if you can do it with multiple values? Now since we have multi-core CPUs, and if you can do operation on multiple elements, it will be awesome, right? And that's where SIMD comes into picture, which is single instruction, multiple data. So let's try that. So let's say enter. Let's see how fast this will work now. Okay, now it is 1000 times, and that is for 512. Let's go for 128. And that's the power when we use SIMD, which will execute multiple instructions, or single instruction on multiple data. It will be much faster. Let's say 128. So let's see how fast it is. It's okay, you can see the numbers. It's 2410x faster than Python. That's crazy. But again, I'm just still waiting for the compiler. No one knows what is happening behind the scene. And you can just try out different stuff. At the end, if you try different things, they will say the speed goes much more than that. Okay, so they also provide something called auto-tune to provide the tuning for different hardware. Okay, we have to run everything, then it works. Ultimately, so this is the thing, right? So we have to run everything, but you can try it out, and once you get the access, but it's way faster. I just wanted to see the speed here, real speed. But again, things are still not clear because we are using a playground. We are not sure of how they are doing behind the scene. A lot of people are saying this is just a promotion from the company. Possible, I can't deny that. But yeah, if it is true, things are changing. Okay, so I'm not sure how many of you will write Python code. Yes, you will write Python code in Mojo, but I think that will be future if this is the real speed which you get. So yeah, that's it from this video where we talked about the Mojo playground and the code and getting hands dirty on Mojo. I will try to make a series once I see the documentation and if I find something interesting. So that's it from this video. See you in the next video, everyone. And make sure that you subscribe and hit the like button if you enjoyed this video. See you in the next video. Bye-bye.